Hey folks, how's it going? This is Mr. Murray coming to you with a video on factoring quadratics intermediate. Okay, so as you remember, we're now into our unit on solving quadratic equations. All right, last unit we talked about how we could convert between different forms of quadratics. In particular, we talked about how we would go from intercept form and vertex form, which you've also seen, into standard form. This through this, we saw the box method, right, for how we multiply. Okay, and then in our last video, which if you haven't seen yet, you need to go back and see. That's the video on intro factoring from 316. We started to talk about some cases when a was equal to 1 and thinking about how do we go from standard form, okay, and by using a method called factoring, right, the box method in reverse, turning it into intercept form. And this we also said is sometimes called factored form because it's like this, but it's been factored as a product, right, of two polynomials. So we sometimes people say factor as a product of binomials. Okay, so this is what we call a trinomial. Okay, it's a trinomial because it has three things, three terms. When you think nomial is kind of like a term, tri meaning three. These are all what we call binomials because each of these has two terms, just x and a constant, and it's a product of binomials because these things are being multiplied by one another. Okay, so in this video, we're going to look at a couple special cases, and we're going to focus on what happens when the a value is more than 1. And what we're going to see as usual, I'm not going to teach any tricks. It's just going to be just the same as before. We're going to factor. We're going to use the intuition we built up so far, and you're going to see it's really not that bad. Okay, so before I move on, I'm again say if you have not seen the first factoring video, please go back and take a look at that. That is from 3/16/2020, yesterday in this case. Please see that if you have not done so already. Okay, so I'm going to jump in here. So as usual, there's going to be some problems that I'm going to do, some problems that we're going to kind of do together, and then ones for you to try on your own. Okay, so here we have, we need to find the zeros. Okay, so I'm going to focus on these zeros. And when I say the zeros, I mean I want to know what does x have to be so that when I plug in, I get 0. Now, by looking at it, we can't really tell. But if I could just make it look like this, right, something like this, like x minus something, then I could see those two numbers right away, and it would be a lot easier. Okay, because remember what we talked about in class. It's really easy to find the y-intercept. It's 0, 3, right? Just plug in 0. It's hard to find the x-intercepts. And here's the other kicker. As you might have seen in the homework, you're not even guaranteed to have any x-intercepts, whereas you are guaranteed to have a y-intercept. Okay, so as we've discussed, what I'm going to do is I'm going to use my box. Okay, so for those of you who are here on the 13th for the Polydoku kind of discussion, what we found is a couple patterns. We found that the thing with x squared is always going to be in the top left, and the number is always going to be in the bottom right? The stuff with the highest power of x is up here. The stuff with no x at all, or the lowest power of x, if you think about it, it's x to the 0, is down there. Okay, so this is going to be a little bit more challenging because here it does matter how you set up your length and your width, and we're going to see what I mean in a moment. Okay, so here I got to ask myself, how can I get 2x squared? Well, I know I have to have an x and an x because that's going to give me the x squared. But how do I get the 2? Well, the only way to get 2 is that one of the coefficients is 1 and the other coefficient is 2. So I get 2 times 1 is 2, x times x is x squared. Okay, if you want, technically 1x is the same as x, so you don't even really need to have the 1 in front of there. I'm going to ask myself a similar question. How do I get 3? Well, the only way we know how to get 3, because 3 is like a prime number, is we have to use 3 and 1. But here's the kicker. Unlike when a is 1, it matters where you put it. Okay, I'm going to look at 2 different scenarios. So I'm going to start by setting up this box on the right exactly where we were right now. Now notice I want to get -7. So what that means is that, look, I've got 2 numbers that multiply to a negative, or multiply to a positive. So either they're both positive or they're both negative. It's the only way you can multiply 2 numbers and get a positive, right? But now I know they add up to a negative number. So what that means is this needs to be a minus, and this needs to be a minus. But notice, watch what happens if I make this a 1 and this a 3 versus this setup right here. So what you can see here is that I've actually flipped the inputs around, or rather the 1 and the 3's around. My inputs rather for these 2 slots. So see, this is a -1, this is a -3, this is a -1, and this is a -3. As you can see so far, it doesn't make a difference, right? -1 times 3, -3 is, sorry, -1 times -3 is 3, -3 times -1 is 3, right? We know the order of doing the multiplication doesn't matter. But watch what happens when I fill in the box. Here I get 2x times -1, and that's -2x. Here I get -3 times x, and that's -3x. And when I combine the like terms in the diagonal, what I get is -5x. Let's see what happens here. Here I do -2x, or rather I do 2x times -3, and that gets me -6x. And here I do -1 times x, and I get -x or -1x. And when I add these up, because they're the like terms, I get -7x. So you can see that it actually is going to make a very big difference where we put the numbers here, because one of them in this case is getting multiplied by 2, whereas the other one is getting multiplied by 1. In the last case examples, right, when a was 1, it was getting, the numbers are getting multiplied by 1 either way, right? That is, this was a 1, not a 2, and this was, right, a 1, just like it is now. So we're going to have to think about that, right? And so what this means is that this cannot be the right configuration because we don't get the right number of x's, but this one is. And so what we know is that 2x squared minus 7x plus 3 equals 2x minus 1 times x minus 3. Okay, and so basically making this equal to 0 is the same thing as making this equal to 0, right? But whereas it's not obvious just by looking what's going to work here, right? You'd have to guess. You could guess 1, you could guess 2, you could guess 3, right? And you'll finally get it. But the problem is you're not going to think about guessing a number like 1/2, which is what makes this 0, right? And if you solve this, if you solve 2x minus 1 is 0, you'd add the 1, you divide by 2, and here I'm going to get x is equal to 3. Okay, but you'd never think that that could be a possibility, right? 1/2, and that's what happens when you work with numbers like this. So our intercept is 1. Our intercepts are 1/2, 0, and 3 is 0. So when I say find the zeros, if I ask for the zeros, those are the zeros. If I say find the x-intercepts, you give me these. If I say factor it, you get me this. Okay, so recap. If I say factor, you give me this one, just the 2x minus 1, x minus 3. If I say x-intercepts, you give me these. If I say either zeros or I say the roots, so those are sometimes used interchangeably, I want you to give me these, okay? All right, so hopefully that made sense to you, and I know in the beginning I tend to go slow through it. As we work through it, it'll build intuition. It's not going to take you a very long time to do all these. What you do need to know is that if you want to be guaranteed the full credit, you have to be willing to put in the time to get that. And it's not easy, but the reason I'm not going to teach you tricks, because believe me, there's a trick to do this. is that if I teach you the tricks, you're going to have to remember the tricks. And the tricks to work with these don't really work that effectively for any other kind of problem. When the power of x, biggest power of x is more than 2, right? You're going to have to remember what to do. It's not going to really work. I would rather teach you, like I said, the box method that you can use for multiplication, division, factoring, one skill for all 3 skills, one tool rather for all 3 skills, then teach you one skill to factor when a is 1, one skill to factor when a is more than 1, right? And then another skill to expand it out, right? That's 3 tools to do what one tool can do. So please just believe me. I've been teaching this for a little bit now. Help me help you and have the grit to stick through this, okay? So I'm going to do another you try right now. And here I go. So remember, the first thing I'm going to do is I'm going to build in my box. Boop. Boop. Okay, now what's going to go where? Well, I know my 3x squared will go up here. My 8 will go down here. So again, 3x squared, there's really only one way you could set this up. I mean, you could have the 3x on the left and the x up top, fine. But really, there's only one way that you can get 3x squared. And that's to take 3x and multiply by x. Now, you could say, Mr. Moray, how come I can't use a fraction? Well, I would say if you could have used a fraction, then there's another way that you could have written it out in an equivalent way without using the fraction. So we're going to stick to whole numbers. Okay, please stick to whole numbers. So in this case, we have 3 and 1 gives me 3. X times x for the x squared. Here's the trick. 8, there's a few ways to make 8. I could make 2 and 4. I could make 1 and 8. Okay, so notice the difference here with 3, you could only have one possibility. It was 3 and 1. And so, you know, where we put the 3 and the 1, yes, that required some thinking. But the reality is, it was just toying with those 2 combinations. Okay, again, we know that the 2 numbers either are both positive or negative because they multiply to a positive. We know they're a negative because they add to a negative. So I'm either looking for -2, -4, or I'm looking for it to be reversed. So I have -4, -2, or I have -1, -8, or I have -8, -1. So if you just think about the fact that those are the only possibilities, already it starts to feel like it's getting a little bit easier. Now let's think about this. The other way to make this easier for you, and I know again it seems like a lot of work, and some of us when we see it work, we kind of flip that switch kind of flips off. But instead, right, though it does seem like there's a few combos, let's see if we can figure out the ones that are not going to make sense. Okay, so right, there's 4 possible combinations. 2, 4, 4, 2, 1, 8, 8, 1. But if we think about it, right, if I put an 8, if I put a -8 here, this is going to become -24. And when I add 1 to -20, or when I subtract 1 from -24, right, I'm not getting 14. So it's not going to be 1 and 8. -8's not going to be here. But also notice if I put -1 here and -3 and -8 here, well, this is going to be 8. This is going to be 11. So 8 and 1 don't work either. Okay, so right, because this would be 3 and this would be -3 and this -8. So just by quickly trying to like work the combos, I've already cut the amount of possibilities that I have to test in half. Just like that. That took like less than 10 seconds to cut that in half. So what I know is that 1 and 8 is not my numbers. So that means it's either got to be -2, -4, or -4, -2. And what I notice is that if I put a -4 here and a -2 here, this would become -12x, this would become -2x, and these would add to -14x. And you know what? Worst case scenario, you get the numbers wrong. And you know what? You take the -2, you erase it, you take the -4, you erase it, and you try another combo. Because when you get something wrong, if you if you look at wrong answers the right way, every wrong answer is extremely helpful. When I got the 8 and the 1 wrong, what that told me is that when I flipped it around, it probably wasn't going to be right either. And that allowed me to eliminate another answer, possible answer rather, really quickly. So you have to look at wrong answers the right way. If you look at them as being helpful to solving problems, you're going to get a lot of mileage there. So what we'll get here is we'll get 3x minus 2 times x minus 4. I like to do the one with a bigger than 1 first. If you had this flipped around, that is, if you wrote it like this, okay, these are both equivalent, you would get a complete 100% credit no matter how you organize them, because they're equivalent. It does not matter what order you multiply. But I'm going to say I would prefer to see the thing without, with the number in front. I'd prefer to see that, so what I'm saying is I prefer to see the arrangement where the ones where the number in front of x is more than 1 go first. And the reason is because when you get into more complicated factoring, you're going to have to continue to look through some of these things as we go, and that's something we'll see more in the future, but like just something to think about, okay? So now if I want to find the zeros, right, instead of making this equal to 0, because this standard form and this intercept form are equivalent, their graphs are exactly the same, right? Because they're equivalent. They're the exact same thing, which means, mathematically at least, which means that anything that makes the standard form 0 also has to make the intercept form 0, right? And anything that makes the intercept form 0 has to make the standard form 0. But note, in the intercept form, well, look, if x is 4, 4 minus 4 is 0, so it's 0, and you could see that by plugging in 4, you get a similar thing. This would be 48. This would be 64, so that'd be negative 8 plus 8. Okay, so again, 48. 48. This would become 48, not 64, minus 56. Okay, 48 minus 56 is negative 8, plus 8 is 0. So you can literally see plugging in 4, in any case, will give you 0. For this one, you might want to set this one equal to 0 manually, so you can add the 2 and divide by 3. But notice, it's at most, at this point, a two-step equation. And what's another thing that's so beautiful about this. You start with this equation with x squareds in it, and you're like, how am I even going to figure this out? But what it boils down to is the kinds of equations we've been solving for years, right? We can solve. So what we're doing is we're taking an equation where there's like, what would I do? And if you look at it like this instead, right, this is all stuff we can do pretty easily, right? Okay, so this is where these beautiful patterns of foiling, or rather boxing and backwards boxing, come from. So please make sure you really understood this, again, with the x-intercepts being 4, 0, and 2/3, 0. Please make sure you understood what I did here. All right, rewind if needed, and then in a moment, I think I'm going to move on for one for us to try. All right, here we go. So we're going to try to find the zeros. Notice it's gotten a little bit spicier here. So the last one, by the way, was spicy because 8 had multiple possibilities. Notice now here, I've got to deal with 4. So when I set up my box, I either have to have 4x times x, or vice versa, right? This order doesn't really matter. So either one of them is 4x and the other one is x, or one of them is 2x and the other one is 2x. Okay, and again, because it's the first one we're going to put in here, it doesn't really matter how we set it up, okay? Because as long as we set up the rest of the box correctly. Okay, so again, we're going to try to think about how can I get everything in there? How can I get 4x squared minus 28x, plus 28x rather, plus 49 into this box? So I know that my 4x squared is going to go here, and now my 49 is going to go here. The good news is this has to either be 49 times 1 or 7 times 7, because 49 is a perfect square, right? It has a whole square root. And one thing you might know about perfect squares is that they're only divisible by 1 themselves and their square root. Think about it. No other number is going to go into 49. Not a single other number will go into 49. If you can find one, that's great, but it's only going to be 1, 7, 49. Okay, this isn't always true for all of them. I bet you we could find another one, but this is the ones that we're going to start by thinking of. I believe that this is true. Like if you look at 36, right? 36 has 6, 9, 4, 1, etc. Okay, so perfect squares are really special and cool like that, right? But I'm doing this in my head. I know 2 is not going to work because it doesn't end in a 0, 2, 4, 6, or 8. The digits don't add up to a multiple of 3, so 3 doesn't work. 4 gets to 48 only. Leaves a remainder of 1. I just did that quick in my head. Doesn't end in a 0 or a 5, so it's not divisible by 5. It's not divisible by 2 and 3, so it's not divisible by 6. And then we get to 7, and we're basically done at that point. So basically what I need to experiment with is they're going to be either 49 and 1 or 7 and 7. Let's think about this. If I do 49 times 4, there's no way I'm getting back to 28. If I do 49 times 2, there's no way I'm going to get back to 28, right? Because the problem is not only are both of them either, we know they're either both positive or negative because, again, they multiply to a positive, but then I actually know that they're both positive because, actually, I want to do it the other way. I know they're both positive because they add to a positive, right? So if I get to 49 and I multiply by 4, I'm already way over 28, so there's no way I'm getting back, okay? It doesn't matter what you multiply by, whether it's 1, 2, or 4. So 49 and 1 cannot possibly be a possibility. And so if you can do that out in your head, you're saving yourself time. So I know what I have to do. One of these has to be 7, and the other one has to be 7. Okay? But what about the other two? Well, if you think about it, right? If one of them is 4, I'm going to multiply by 4. 4 times 7. Let's say this was 4. Let's say I took a guess. Take a guess. 28, 28x. This would become 28x. This would become 7x. So we'd get 35. That's not going to work. Okay. So what? We took a risk. It's all right. You know what that tells us is that 4x and x isn't going to work. So we're going to use 2x and 2x instead. See if that works. So we get 4x squared. This becomes 28x, and we get 49. Perfect. So we know that 4x squared plus 28x plus 49 is equal to 2x plus 7 times 2x plus 7, which is equal to 2x plus 7 squared. Now, one thing worth noticing, notice that this is a perfect square. This is 2x squared. This is a perfect square, right? We saw this is 7 squared. So when A and C are both perfect squares, it's worth considering whether the whole thing is a perfect square, which it is, right? Because this whole thing is 2x plus 7 squared, okay? Now, as a result, well, if I want to find what makes this 0, the same thing as finding what makes this 0, right? And in this case, because we have these repeating factors, there's only going to be one number, and it's going to be negative 7/2, and that's it. So that's actually pretty cool, because what this shows is that I could have two x-intercepts, like here, or roots, or I could only have one. Eventually, maybe probably next year, we're going to learn a formula, when we're working with these kinds of quadratics, that will tell us right away, once we plug in, whether I'll have 0, 1, or 2 roots or x-intercepts. Okay, and so then negative 7/2, 0 is my x-intercept. So this is my x-intercept, this is my 0, this is my factor. Okay, so just please make sure because one of the big mistakes that I'm seeing coming out of 10th graders this year, especially those who had me, and I take responsibility for that, is that sometimes we're struggling with what answer do I give. So you need to know, if I ask you for factored form, I just want to see the thing times the thing, and you're done. If I ask you for an x-intercept, I want to see a point where I have an x and then y is 0, because that's what should happen. You plug in negative 7/2, 0 comes out. If I ask you for a 0, then that's where I want x equals. So you should never tell me what x equals unless I am giving you an equation. If I do not give you an equation, right, if I just say factor this and I give you this, you don't see an equal sign here, you shouldn't have an equal sign in your answer. Because some people like to actually take it one step further and say x equals this, but you have to step back and ask yourself, what was I asking you? Was I asking you for what x is, or was I asking you to factor? Okay, so you gotta be really careful with regard to your directions. All right, so another example we can try is this one right here. So this one's gonna be tough because of how 6 breaks down. So again, I can have 6 break down as 6 times 1. I can have 6 break down as 3 times 2, right? So you can see what makes this difficult is the increasing number of ways that the A and the C can break down. Okay, that's where things get tricky. All right, 7 I get lucky because 7 has to be 7 and 1. There's no other way to make. I suppose we could have 1 and 7. So I do my check again. I notice this is positive, which means I need to have either a positive and a positive, or a negative and a negative. I check this number, it's a negative, right? And so they must have 2 negatives, because the only way to have 2 numbers multiply to a positive and add to a negative is that both of them have to be negative. Again, we're assuming that these numbers are always positive, so they're not really factoring into the equation. No pun intended there. All right, so I'm now going to try to play with some numbers here. What I notice again is immediately, and I always write the 6 times 1, and I recommend you do that because, again, a lot of people sleep on 6 and 1 as a possibility, but it actually surprisingly comes out to work more than you'd think, right? When it's a prime number, it's basically your only choice. But believe me, don't discount the possibility of 6 and 1. All right. So I take a look here, and I do 6 times 7. I notice if I do 6 times 7, there's no way I'm getting back to 13, even, right, because they're both negative. So I do 6 and 7, I'm already at negative 42. I'm only going to get more negative. So it's not going to be 6 and 1. Now, if I multiply the 6 in them, but notice, so I'm going to try it like this. So I'm going to do another possibility. So notice, I just want to recap. I did negative 1 and negative 7. Remember, I knew they both had to be negative. So these get me my 7. This gives me my 6x squared. And I get negative 42x. So these I can see become negative 43x. Okay, so I got it wrong. So what? That's okay. Try another combo, right? Look, there's 4 possible combinations. You take a guess, you got a 1 in 4 chance of getting it right. But once you're wrong, you now have a 1 in 3 chance in getting it right? Because every answer you eliminate increases the probability that the remaining answers are correct. Either you get the right answer and you're done, or you improve your odds that your next choice is correct. Then you have a 50-50 chance, right? Then you have a 100% chance. So now, what if this was my negative 7 and this was my negative 1? So I get negative 6x, negative 7x, and negative 6x plus negative 7x is 13x. Perfect. So I'm done. So what I get is 6x minus 7, x minus 1. Okay, we've gotten a lot of negatives here. Okay, don't always expect this to be negative. Sometimes you're going to get a negative c value, and then remember that means one of your numbers is positive and your other is negative. So it's going to present its own challenges. Okay. So now what I'm going to do is, what do we do here? We're going to take each one and we're going to set it equal to 0. Nice. So here we go. So I have 6x minus 7 is 0. So 6x equals 7, adding to both sides. So x is 7/6. Or x minus 1 is 0. So x is 1. So I have 2 zeros, 1 and 7/6. Okay. And think about it. Yes, if you had plugged in 1, you could have potentially gotten by luck a 0. But think about it. By plugging in 1, 2, 3, 4, 5, you could be plugging in numbers forever. You're never going to, I highly doubt anyone would guess 7/6 as a possible answer. Okay. If you do, good for you. I think you should consider going into business as a psychic or some kind of clairvoyance. Okay. These are x-intercepts. So remember, x-intercepts, roots, or zeros. Okay, these x equals and then factored form is this. Okay, so these are a couple of retries. Please make sure you understood what I did here. And then in a moment, I'll move on to a couple for you to try. All right, so here we go. So here's a couple for you to try. So what I want you to do is take a look at this quadratic right here. We have 2x squared minus 7x minus 15. Okay. Notice here the difference is that now that this final number is negative, so that means we need to have one number be positive and our other number be negative, right? Because remember, we're going to have our things that multiply to 2x squared and then our numbers that multiply to negative 15, right? So what I'm saying is we know that one of them is negative and one of them is positive. Okay, so what I want you to do is go ahead using whatever method you want. Again, I've taught the box. I recommend the box. I want you to pause the video. I want you to factor this quadratic and find the zeros and x-intercepts. And then when you're ready, unpause, and I'll show you how to solve. All right, so first thing we do again, we set up our box. Okay, I'll do this a different color. Now, remember, what's going to go inside of here? Top left, that's 2x squared. Bottom right is going to be negative 15. Now, how could I get 2x squared? So I did this as the first you try because I wanted you to first have a chance to try one where you only have one way to get the a value. One of them has to be 2x, the other one has to be x. There's just no way around it. It's unavoidable. Okay, now how do I get 15? Well, I could do 15 and 1. Keeping in mind, I could do, negative 15 and 1, 15 and negative 1. The only other way to get 15 is 3 and 5. Now, if I know that if I put 15 here, whether it's positive or negative, this is going to become 30. There's going to be no way to get back down to 7. So what that tells me is that no matter what, 15 and 1, it's probably not going to work. So what I've done, just by quickly tooling around with it and thinking about, wait a minute, if I'm playing around with 15, there's no way to do 15 and 1 and 2 and all that. I can't get 7. I can see that pretty clearly. I've already eliminated half of the choices. So what that means is just by doing taking a second to putting that effort into a quick little elimination, I've now have a 50-50 chance of guessing correctly. Okay, and so what I need to do is I need to use 3 and 5. So what I'm going to try is I'm going to try this as negative 3, and this is 5. So 5 times negative 3 is negative 15. 2 times x is 2x squared. This becomes a 5x. This becomes a negative 6x. Add these together, and I get negative 1x. Okay, so what that means is I need to erase. I was not correct. Okay? So remember, what I did is negative 3 and 5. What if it's 3 and negative 5? Maybe it's just I messed those up. So I'd get negative 5x and 6x. This would be positive 1. So all that did is make it from positive 1 to negative 1. And that's true in general. If you flip the signs around, generally speaking, you make one negative and the other positive. You just flip the signs around, and you're just going to flip the answer around, right? So instead of doing negative 6 plus 5, I did 6 plus negative 5, right? So you're just going to get flipping the signs doesn't generally do anything helpful. It's worth trying, but it generally doesn't help. So what I did is that means that it's not the signs that are wrong, it's the numbers that are wrong, right? So notice how I took a situation where I didn't have where I had some wrong answers, and I used that to inform what the correct answers are. Now, I'm not practicing what I preach, but I do recommend that you actually do the boxes out separate. So I erased and kind of retooled. If you actually take the time to just make a brand new box, it's not that hard to do top left and bottom right again. And then you can actually use your old work, because the thing is, once you erase it, you might forget what combinations you use, and you might use a combination again. But if you make each box, you get a sense of, one, what did I do right, what did I do wrong, and how do we need to retool this to go at it again. And by having that grip, you see that I get finally an answer, right, on my third try, where I get negative 10 plus 3. for negative 7x. So my factored form is 2x plus 3 and x minus 5 is 0. If I'm finding the zeros, rather. So here's factored form, the two things multiplied. The zeros are going to be negative 3 halves and 5. And the x-intercepts are going to be negative 3 halves, 0, and 5, 0. Okay, I don't like how I did there. So again, third time's a charm. There we go. So this is factored. These are x-intercepts. Nope. These are zeros / roots. And these are x-intercepts. Okay? Alright, so please make sure you understood that. If you got this one right, amazing. Congratulations. I'm proud of you. Please make sure you understood what I did here. Then in a moment, I'm going to move on to another U-track. Alrighty. Here's another one for you to try. So again, I want you to take a look at these numbers here, this quadratic. I want you to pause the video. I want you to try to find the factored form, the x-intercepts, and the zeros. So I want factored form, x-intercepts, and the zeros. Okay, so pause, find me this information based on the quadratic, and then when you're ready, unpause, and I'll show you how to do it. Alrighty, so again, we're just going to try to box this one out. So I know what goes here. It's going to become 4x squared. What goes here? 9. So how do I get 4x squared? Well, this has to be a couple different ways. Not necessarily. So here I've got a 4 and a 1, or a 2 and a 2. Here I've got a 3 and a 3, or a 1 and a 9. I know they both have to be negative. So it would have to be negative because they multiply to a positive and add to a negative. So it's negative 3, or negative 1, negative 9. I get lucky because it's not a positive and a negative, so I don't have to worry about putzing around with the signs. That makes a difficult problem all the easier. So I essentially have, I could do 4 and 1, 3 and 3, 4 and 1, 9 and 1, 4 and 1, 1 and 9. So I basically have 6 different boxes if I want to really brute force this. Okay, instead, let me think about this real quick. I need them to both be negative, and they have to add to negative 12. So if I choose 1 and 9 as my numbers, it's not going to work. Because if I do 4 times 9 and 1 times 1, I'm way over. I'm at negative 30. If I do, right, negative 1, negative 9, so negative 1 times 4 is negative 4, plus negative 9 is negative 13. If I do negative 9 with the 4, I get negative 36. No way. So 1 and 9 and 4 and 1 do not work. What if it's 3 and 3? Well, if I do 4 and 3, I get 12. No matter how you spin it, you're going to have a 12. So you're going to get negative 15 either way. That's that. So 4 and 1 is not a possibility. Right? See how I intuited that real quick? If you didn't get what I got, set up a box real quick and do it out, and you'll see it's not going to work. So what that means is that this has to be 2x and this has to be 2x. But what do the other ones have to be? Well, if I make this a 9, a negative, it'll have to be a negative 9 to get, because we want a negative 12. I'm already over. I'm at 18, negative 18. And it doesn't matter, right? If I put the negative 9 on the other part, right? Well, right, if I'd put the negative 9 here, then it would have been still, the negative 18 would have still been the issue. So it's not a negative 9. So that means 1 and 9 can't be a possibility. So it means the combination is 2 and 2. And the good news is negative 3 and negative 3, because there's the same, it doesn't matter where I put them. So I get negative 6x for a negative 12x. So what this is equal to is 2x minus 3. And what we should write this as, when we have these the same, 2x minus 3 and 2x minus 3, the correct way to write that is 2x minus 3 squared. And now, if we recall, how many x-intercepts slash zeros am I going to have? I'm only going to have one, and that's because there's only one unique factor. So this is factored form. The factors are, in this case, are both the same. So there's only one factor that is unique, right? And that's 2x minus 3, right? There's not a different factor from 2x minus 3, right? So if both the factors are the same, I only have one actual factor. It's just repeated. That means I'm going to have, for each factor, you have an intercept. So that means I'm going to have one unique x-intercept. Now, if you do this, if you forget to square it by accident, and you calculate it without squaring it, do the intercepts, what's going to happen is you're going to get the same number twice. And that's going to tell you that you're not going to repeat it, right? If you get 3 halves and 3 halves, once you tell me you have a 3 halves, I don't need to know that you get it for both of them, okay? So if I want the x-intercepts, right, and the roots, so I would make this 0, I would add 3 and divide by 2. So there's my 0, or root, and my x-intercept, x is 3 halves, y is 0, okay? So please make sure, folks, you understood what I did here in this U-try. Rewind if needed, and then in a moment I'll move on to a last discussion of some special cases. Alrighty, so I'm going to take a look at a couple more special cases here with you today. As we move on through the rest of this unit and we move on into next year, factoring is going to play a very big role. As it looks next year, the idea is to continue our investigation on how to solve quadratic equations by teaching you a couple more methods for how to work with standard form, because factoring is not always going to work, as you might have already seen. But just because factoring works, the problem is when you have a situation with no x-intercepts, there will be no factors. But when you have a situation when you can't factor, that doesn't necessarily mean there's no x-intercepts. I could give you examples of ones that your roots are going to be like the square root of 3 and 2 plus the square root of 5 over 7. You're never going to be able to come up with the factors for those because they're so wacky and they're just so irrational that you're never going to be able to think about those factors. But they're roots nonetheless. Okay, so as we get into factoring, we're going to move next year into polynomials that have more than just x squared. So we could see cubics, where the biggest power of x is x cubed. You could see quartics, where the biggest power of x is x to the 4th. You could see quintics, where the biggest power of x is x to the 5th. And you may need to factor things like that, okay? And so what we're going to do when we talk about that is we're going to need to know how to do this kind of factoring with quadratics, because our goal is going to be to boil it all the way down until we have a quadratic, and then factor the quadratics using the skills we've learned this year. So please, these are things to think about. So when I take a look at this first one, I noticed there's a 2x squared, an 8x, and a 90. So one thing we need to start looking at, because it makes our lives easier, especially when you're dealing with an a that's more than 1, is think about, do these terms all have anything in common? And the answer is they do. This has a 2 in it. This has a 2 in it. It's 2 times 4. And this has a 2 in it. So when we see a common factor, what we can do is we can take the common factor, we can bring it outside, and we can what's called factor it out. Okay? Because you can see if I take the 2 and redistribute it, I get 2x squared minus 8x minus 90. So these must be equivalent to each other. But now you see, I don't have to worry about factoring when a is more than 1 anymore. If I do, well, I'll show you what happens, but I don't have to think about that. And that's cool because it's easier to factor when a is 1. So what I'm going to do is I'm now going to factor this, and when I factor it, what you'll end up getting is x minus 9 and x plus 5. Now, if you did box this, let's say, there's a couple different things you could see happening. You'd get So this would be 2x squared and negative 90. So for example, what you might get is you might get 2x, you might find that 2x plus 10 will be one factor, while x minus 9 will be the other. And you can see this works because this is 10x, and this here is 18x, negative 18x, and 10x minus 18x is negative 8x, so it works. And so notice what I get is 2x plus 10 and x minus 9. But what do you notice about 2x minus 10? There's a 2 in it, right? So I can even take the 2 out and get 2 times x plus 5, because you can see if I distributed that, I'd get 2x plus 10. And remember, the distribution works because the power, the implied power on this factor, because there's no exponent, is 1. Okay, so that's one special case. A case where you can factor out a number that they all have in common, right? And remember, we call this a GCF, a greatest common factor. Okay, so when the greatest common factor of your coefficients is not 1, you can remove that greatest common factor. And what's also cool is if you don't get it right on the first try, for example, if the GCF is 4 and you take out a 2, you can then take out another 2. Okay, so that's another thing we might see a little bit further down the line. Here, x squared minus 9x, there's also a GCF, except here, the GCF, just like you could take out a number, here we notice there's an x in both of them. So just like you can take out a number as a GCF, you can also take out a variable. So I take x out of x squared and I get x, and you can imagine multiplying and getting x squared. I take an x out of the 9x and I get a negative 9. Okay? And so this would be easy to find the x-intercepts if I wanted to, because one of them would be 0 and the other one would be 9. Okay, but see how this starts with a situation where I'm like, man, c has to be 0, but they have to add up to negative 9? How would I get that? It takes one of those problems where we don't know where to start, and by factoring out the GCF, it boils down to one where we can solve it relatively quickly. Okay, last one I'm going to show you is again, and I'd recommend you take a look at last week's, or rather yesterday's video. This is a difference of squares. Okay, because here I want to find out, I need two numbers that multiply to negative 81 and they add to 0. What? Well, that's easy. What if I take negative 9 and I add it to positive 9? Well, negative 9 plus 9 is 0. Negative 9 times 9 is 81. Now, we know that the adding and multiplying doesn't always work, right? Especially when a is more than 1. But notice that if this is 5x and this is 5x, then 5x times 5x is 25x squared. And here we know that because this is going to be a negative 45x and positive 45x, these will cancel out, right? So this is also a difference of squares. It's 5x minus 9 times 5x plus 9, or 5x plus 9, 5x minus 9, okay? So folks, I hope you found this video to be informational. Thank you for taking the time to watch it. This is a little quick recap of factoring when a is more than 1. At this point, I want you to please go ahead and take a look at the practice that I've distributed, page 2 in particular. It's going to focus on cases where a is more than 1, as well as when a is equal to 1. Going forward, I would expect that I will assign you some more in-depth practice of this kind of factoring problems. So please make sure you can understand it. If not, please go ahead and rewatch anything you need to. Send me questions. I definitely want to have a Google Hangout session soon for those of you who might want to ask. All right? And stay positive. Remember, you can do it. All right? Thanks so much for watching. Have a wonderful day. And don't forget to love math.